5-6 is inequalities in triangles. Okay, you're moving on. Move on, move on. You're moving on. Inequalities in triangles, okay? iPads away unless you are taking notes on them right now. Unbelievable. So there is a property called the comparison property of inequality. I'm not so concerned about the name of it, but here's what it says in dealing with inequalities. If A is equal to B plus C, and C is a positive number, C is greater than 0, then it will always be true that the value of A is greater than the value of B, okay? So think about that. If A equals B plus C, okay, and C is a positive number, if C is positive, then C needs something added to it, B, in order for it to equal A. So that means A always has to be the bigger number between A and B, okay? That kind of comes into play with the triangle exterior angle theorem. Do you remember doing the triangle exterior angle theorem? Where we looked at a triangle like this, and if this was angle 1, and this was angle 2, and this was angle 3, we said the measure of angle 1 is always going to equal the measure of angle 2 plus the measure of angle 3. Well, that means that angle 1 is always going to be bigger than angle 2 or angle 3, because 2 and 3 have to be added together to equal that angle 1, okay? It's just a corollary. It's an add-on to the triangle exterior angle theorem. So basically in this, we're saying the measure of angle 2 will always be bigger than measure of angle 1. I wrote that wrong. Measure of angle 1 will always be greater than the measure of angle 2, and the measure of angle 1 will always be greater than the measure of angle 3. Okay, that's what the corollary says. So if that's the case, and I give you a picture that looks like this, and you have to bear with me here because it doesn't always turn out quite as beautifully as the book would do it, but you'll get the point. So this is angle 3, angle 4, angle 1, and angle 2. Close enough. If you look at this setup, okay, the question is, why is the measure of angle 2 greater than the measure of angle 3? Okay, so I'm telling you right now, 2 is bigger than 3. But why do we know that? Does anyone see a path based on what we just talked about of how we could explain that 2 is actually greater than 3? Because you can eyeball it.
1 is greater than 3 and 1 equals 2.
Right, why is 1 greater than 3? The triangle exterior angle theorem, right? I know that the measure of angle 1 equals the measure of angle 3 plus the measure of angle 4, right? That's the triangle exterior angle theorem. This exterior angle is going to equal the sum of these other two, right? So 1 equals 3 plus 4. Why are 1 and 2 the same? What kind of triangle is that, Angelina? It's isosceles, right? So if I know angle 1 is bigger than, or 1 equals 3 plus 4, then 2 equals 3 plus 4, right? So we could substitute that. The measure of angle 2 would have to equal the measure of angle 3 plus the measure of angle 4, which means that then the measure of angle 3 is going to be smaller than the measure of angle 2 because 3 needs 4 added to it. Right? So, therefore, the measure of angle 2 has to be greater than the measure of angle 3. Okay? Don't stress too much about that type of problem. If that's a whole lot of measure this and measure that, that's throwing you off, it's okay. There's not like some crazy question that tells you, write a proof explaining why this angle is bigger than this angle. But I want you to understand the relationship between them, okay? Okay, so where we spend more of our time in this section is on a couple theorems. The first one is Theorem 510. You don't need to know it. But basically what it says is if two sides of a triangle are not congruent, then the larger side lies opposite oh, I said that wrong. The larger angle, my bad. Erase that. That's the other theorem. That's the next theorem, which is nice. They're just reverse of each other. The larger angle lies opposite the longer side. Okay, here's what I mean by that. Let's say we have a triangle that looks like this. This is A, B, and C. Okay, basically what we're saying is if AC is bigger than AB, then the angles across from them will be the same comparison, right? So AC, let's just do a different color here. AC has what angle across from it? Angle B, right? So if AC is bigger than AB, then angle B is going to be bigger than what side is across from AB? That would be angle C. So AB has angle C across from it. Okay, so the longer the side, the bigger the angle across from it. The shorter the side, the smaller the angle across from it. Okay, so in other words, let me just draw you another picture. Okay, if this is X, Y, and Z, if I tell you that this is 8, 9, and 10, okay, you should be able to tell me what's the biggest angle, what's the smallest angle, and what's the middle angle. Okay, so across from your longest side is your biggest angle. So which angle right now is the biggest angle? Y. Angle Y. So across from the longest side, if I wanted to go, I don't remember, I think I usually have you go smallest to largest actually. Let's just say we're going to go smallest to largest here, okay? Your smallest angle is which one? What's your shortest side? The 8, right? XY. So across from the shortest side would be your smallest angle. So angle Z would be the smallest. Then which one?
Angle X.
Then angle X. Across from the 9, angle X. And then across from the 10, angle Y. So if I was listing my angles smallest to largest, that's what we would do. Does that make sense? Who said no? Let me give you another one. Okay, so that's technically like example, well, this will be example 2. Let's say I have this triangle. This is A, B, and C. This is 175. This is 120. And this is 105. Okay? Across from the biggest side is the biggest angle. Across from the shortest side is the smallest angle. So what is my smallest angle right now? If we're going to go smallest to largest on our angles, what's my smallest angle? Angle B, right? Across from my shortest side. Here's my shortest side. Okay, the angle across from it is that angle B. So smallest would be angle B. What's the next shortest side? would be angle A, because BC is 120, and across from the 120 would be angle A. And then my longest side is the 175. Across from that is angle C. Is that better, Kenny?
Yeah. It's just weird because like it doesn't look like it would be that way.
You don't think those angles look like they're in that order?
I don't know. That's the way I see it. I mean, I get how it works. It just doesn't look like that.
Well, and I maybe didn't draw it perfectly to scale either, but I would say B looks the smallest to me. C definitely looks the biggest, right? C is obtuse and the other two are acute. Okay, there's also the reverse of that, okay? The second theorem just says the opposite with, instead of going from sides to angles, now we go from angles to sides, okay? And I'm not going to write this theorem out because it's really the same thing. Basically what it's saying is if I have a triangle, and this is A, B, and C. If B is 100 and C is, we'll say 50, and A is 30, okay? If those are the angles in my triangle, the smaller the angle, the shorter the side across from it. So now if we're going to do our sides from shortest to longest, okay? Now we need to name them as sides, not angles, right? And hear me right now, because this is what people always do on the test. I say, name your sides from shortest to longest, and they tell me angle A, angle C, angle B. What's wrong with that? Those are angles, right? Not sides. Be very careful, okay? You want sides. You want segments from shortest to longest. So what we're going to do is we're going to look at what sides correspond to which angles. Now, in this one, what is my smallest angle? A. What's the side across from A? BC. So you're going to go across from A and say BC would be the shortest. What's my next shortest? AB across from the 50, right? So AB would come next. And then my longest is across from the 100, which is AC, okay? Please, 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 just read the directions very carefully. If I ask you for angles, name angles. If I ask you for segments, name segments, because that is where most people make the mistakes on this, is they just tell me the wrong thing, okay? Which, if you stop and think about it, don't give me the numbers that I'm giving you, right? If I'm giving you sides, give me angles. If I'm giving you angle measures, give me sides. I wouldn't make it that easy. That's just too easy, right? Yeah.
Why is after BC AB? Not like AC.
Because AB, right, this side right here is across from the middle angle, right? The smallest angle was 30. So that brings us to BC. The next smallest angle is 50. Well, the side across from 50 is AB, right? The biggest angle is 100, and across from that is AC. Okay? Okay, so here's example 3 for you. Let's say I give you this triangle, which is not necessarily drawn to scale. Don't try and measure these things with a ruler. It's not going to work that way. If I tell you this is 58 and this is 62, and I want you to give me these sides from shortest to longest. Okay, so you're naming the sides of the triangle from shortest to longest. Anyone see the first issue we run up on? We don't know T, right? Can we find T? Yeah, very easily, right? It has to add up to what? 180. So if we have 58 and 62, you say 180 minus 58 minus 62 leaves you with a 60-degree angle, okay? So find that angle and write it in. Now you can put your segments in order. So what is my shortest segment going to be?
58.
That's not a segment. But that's what people are going to do on the test, right? Be careful with that. So across from the smallest angle is TV. So TV is my shortest side, or VT. That's the same answer. What one would come next? UV. 60 would be the next smallest angle. Across from that is UV. So what's my longest side? TU. Okay, so you're just listing them in order, shortest to longest or smallest to largest if it's angles. Questions on that? Okay, then there's the triangle inequality theorem, and that just says the sum of any two sides of a triangle has to be greater than the third side, okay? Which, if you want to write that out, you are more than welcome to. It's the triangle inequality theorem. Okay, it says the sum of the lengths of any two sides of a triangle is greater than the third side. Okay, the sum of the lengths of any two sides of a triangle is greater than the third side. Okay, stop and think about what that means. In other words, if I have this triangle, okay, this is X, Y, and Z, it has to be true that XY plus YZ will be bigger than XZ. Okay, it has to be true that XY plus XZ, not equal, sorry, greater. My brain is not functioning properly right now. My apologies. XY plus XZ has to be greater than YZ, and it has to be true that XZ plus YZ has to be greater than XY. So if I take any two sides and add them together, it will always be bigger than the third. Here's why. Let's say I have a triangle. If this is 5 units long, and I go 3 and 3, right? The 3 and 3 are going to meet up. But what if I go 5 here, and I go 2 and 2, right? Even if I laid those flat, the 2 and 2 would go to here and here. I'd have this 1 unit gap in between. So I should be able to add 2 plus 2, and it equals more than the third side. Well, 2 plus 2 is 4. That does not equal more than 5, right? Even if they're equal to each other. If this is 5, and this is 2, and this is 3, if I lay those flat, they'll meet up. Does that make a triangle? No. So you have to be able to add two sides together and make it more than the third side by itself, or they won't ever make a triangle. Right, Devin?
What if it's like a triangle that has like 3, 6, and like 24?
Because 3 plus 6, right? If you laid those flat on the 24, 3 is only going to go to here. 6 is only going to go to here. You're going to have all this gap in between. They'll never touch on the other side, right? So you have to be able to say 3 plus 6 is more than 24. It's not, so that doesn't work. Okay? Okay, so let's just check some numbers and see if they work. This is example 4. How are we doing on time? We're good. Does it make a triangle? Okay, so that's our question here. Is this set of numbers going to make a triangle? So if I give you the numbers 3, 7, and 8, can you make a triangle using those numbers?
No.
Yes, you can, right? Because basically we're saying 3 plus 7 has to be greater than 8. Is that true? Yes. 3 plus 8 has to be greater than 7. Is that true? Yes. And 7 plus 8 has to be greater than 3. Is that true? Yes. So if all three of those work, where you add 2 and it's bigger than the third, then you would say, yes, that's going to make a triangle. Okay? What about, does it work to use 3, 6, and 9? Why not? 3 plus 6 is not greater than. Notice it equals it, right? But equal doesn't work. It has to be greater than. 3 plus 6 is not greater than 9. So you don't even have to try the other two. If you find one that doesn't work, it doesn't work. Okay? So that would be no. 3 plus 6 does not add up to more than 9, so that's not going to make a triangle for us. Okay? So that's the idea of the triangle inequality theorem. But now what if they only give us 2 lengths and want to know what are the possible lengths for your third side? Well, you can kind of use that same idea to figure it out. So let's say this is example 5. I only have 2 more. We're almost there. If I tell you a triangle has lengths of 8 centimeters and 10 centimeters, what are the possibilities for the third side? Okay, well, here's how you can think of it. We know that the sum of 2 have to be greater than the third. What's the length of the third side for us right now? X. We don't know, right? So call it X. So basically we're dealing with sides of X, 8, and 10. Well, if you set up your 3 inequalities, X plus 8 has to be greater than 10. X plus 10 has to be greater than 8. And 8 plus 10 has to be greater than X. Okay? Do you know how to solve an inequality? I'm doing this with my algebra students right now. You all should tell me, yes, I know how to solve an inequality. You would take away 8 here, right? So X is greater than 2. You would take away 10 here. So X is greater than negative 2. And this one, you simplify. 18 is greater than X, okay? But now here's the thing. You have 3 numbers. We want a range. It's got to be between this length and this length. Which 2 of those 3 do you suppose you're going to use? X has to be greater than 2 and less than 18. Why? Why can we not use X is greater than negative 2? You can't have a side that's a negative length, first of all. And if X has to be greater than 2, it's going to be greater than negative 2. So forget the negative, okay? Your answer is it's going to be between 2 and 18. Does that include 2 and 18? No. It has to be between them, okay? Now here's the beauty of this. This is the long version. Plug in a bunch of inequalities and solve. Anyone see a shortcut? Look at our answers and look at the numbers we started with. You started with 10 and 8. Add them, you get your high end. Subtract them, you get your low end. Okay? So you can do that every single time. What if I gave you a triangle with sides of 7 and 13? What's your range? What's your low end? 20 would be the high end, right? And 6 when you subtract them. So technically, you don't have to do all that inequality work because every single time it will be the sum and the difference make your range. Okay? Add them together, get your high end, subtract them, get your low end. Sorry, will you put that away? Does that make sense? Okay. Last one. And I promise you there's one, like every one of these examples, the last 4 examples we do in this lesson, there's one like each one of those on the test. So make sure you're with me on this. Last example. And this is probably the one that people get wrong the most on the test. So stick with me here. This is not drawn to scale. Use the numbers you're given, not what you think it looks like. Okay, you have this picture. I want to know in this entire picture which segment is the longest. Okay, in this whole picture, which is the longest segment? So there are 1, 2, 3, 4, 5 segments. Which one's the longest? Anyone have any idea where we start? Aaron. Find the two missing angles first, okay? So forget about the fact that you have two triangles. Look at one triangle, okay? So triangle ABD has 59, 61. Your other one would be 60, okay? Then look at the other triangle. You have 57, 60, and the other one would be 63, okay? Now here's the deal. There is no AAA postulate, remember? So just because your angle measures are a certain size doesn't mean your sides relate to those so much, right? The sides could be longer even if your angle's smaller if we just blew up the triangle, okay? That's where you have to remember and be cautious because that's where everyone does it wrong because everyone looks at this problem and they tell me which segment's longest. Guesses? They say BD and they are wrong, okay? Here's why. BD is the longest in which triangle? BCD, right? In this triangle, your biggest angle is here, which means your longest side is here. Okay? Now forget about the triangle on the right and look at the triangle on the left. In this triangle, which side is the longest? AD. This side here. Okay? So you have AD and BD are your longest sides. Which one's longer?
AD.
Why?
Because 59 plus 60 is more than 60 plus 57.
No. You don't have to add anything. Here's the deal. This is the triangle we're looking at, right? Whichever triangle has the two longest, just use that one. Forget about all this. It's not helping us anymore. Okay, because we found out this middle one was the longest for that one. Well, it's also a side in your other triangle. And in that other triangle, between those two, the longer one is the one across from the 61, not the 59, right? So that means that AD is my longest side in this figure. Does that make sense? So find the longest in both. I always do a little squiggly. I always go, okay, well, I know this one's the longest in my right triangle. I know this one's the longest in my left triangle. Once I know the two that are the longest, I compare in that triangle that has them both. Well, the triangle that has them both is this triangle. In that triangle, the 61 is across from this side. 61 is my biggest angle, so this AD has to be my biggest side. Questions on that? Okay. As you do this homework,